It's a red Goliath star. Assuming you put it where the sun is, it would stretch out to the circle of Jupiter. It's tremendous, entirely temperamental, and going to detonate. These blasts are among the greatest eruptions of radio energy in the whole universe, producing more energy than a billion suns. Are you prepared for what is going to happen? Creepy Crawly Juice, a monstrous red, very monster star, and one of the nearest stars to Earth, has as of late gone through a striking diminishing that has caught attention and blended feelings worldwide. This diminishing has driven to hypothesis among stargazers and the public about its expected ramifications. A few researchers believe this strange conduct could be a forerunner to a cosmic explosion, a destructive occasion that happens when a star debilitates its atomic fuel and implodes under its own weight, prompting an enormous blast. Such an occasion raises concerns not just among established researchers, but additionally among the general public, as it offers conversation starters about the expected effect on our own planet. Bug juice is a noticeable part of the heavenly body, or which is easily recognizable in the night sky due to its unmistakable shape and brilliant stars. Also referred to as Alpha Orionis, it holds the title of the most brilliant and largest star in this heavenly body. Ongoing information gathered by NASA's Hubble Space Telescope, alongside observations from different observatories, have shown that scarab juice encountered a huge mass infusion in 2019. This conduct is extraordinary for a star of its kind and has provoked the interest of stargazers overall. While coronal mass ejections are a typical event in our own sun, the unique event seen in bug juice adds an interesting layer to how we might interpret heavenly life cycles and the elements of monstrous stars. The distance to creepy crawly juice remains a subject of discussion among stargazers. Some estimates propose it is farther away, while others indicate it could be as close as 724 light-years from Earth. Accurately determining the distances of red giant stars like bug juice is a perplexing test due to their tremendous distances and unique attributes. Scarab juice stands out as one of the most brilliant stars visible in our night sky, flaunting a radiance roughly 1,000 times more significant than that of the sun. However, this unimaginable brilliance comes at a tremendous cost. Bug juice drinks its atomic fuel at an accelerated rate, hurrying the inevitable finish of its heavenly life. Eventually, the star will deplete its fuel supply, prompting a dramatic breakdown under its own gravitational pull, potentially resulting in a cosmic explosion blast that could give birth to a neutron star or even a black hole. Should our current astrophysical speculations turn out as expected, this raises a significant inquiry. Does bug juice represent a danger to Earth? If a cosmic explosion were to happen only a few light-years from our planet, the outcomes could be annihilating. The blast of a supercosmic explosion can discharge an extraordinary amount of light, possibly matching that of a whole galaxy. In this way, regardless of whether scarab juice is somewhat far off like the star Alpha Centauri, the impacts of its cosmic explosion could be significant and expansive. Strikingly, since the last cosmic explosion seen in our own universe in 1604, humankind still can't seem to witness such an occasion locally. However, a remarkable cosmic explosion happened in 1987 in the Large Magellanic Cloud, found 169,000 light-years away. While that occasion had massive impacts, it represented no immediate danger to Earth, filling in as a sign of the scale and expected effect of such galactic events. The concept of a risk zone encompassing a typical cosmic explosion is fascinating and could have serious ramifications for life on the planet if a cosmic explosion were to happen nearby. By and by, it's essential to comprehend that in the enormous cosmic scene, cosmic explosions are relatively small events when compared to gamma-ray bursts, which are vastly more powerful and represent a different kind of danger. Supernovae can have wrecking impacts capable of crushing biospheres and immersing worlds with deadly radiation. For instance, a specific kind of cosmic explosion can lead to the obliteration of a planet's ozone layer, leaving it vulnerable to the unforgiving radiation of the universe long after the blast has occurred. This possibility was featured in a recent study that presented new potential risks related to gigantic stars that end their lives in a spectacular style. When giant stars detonate in a cosmic explosion, they can reach some of the most noteworthy luminosities known in the universe. In fact, the brightness of a solitary cosmic explosion can eclipse the combined brilliance of many billions of stars. This raises the question of what the ramifications would be if creepy-crawly juice were to go through such a blast. If a cosmic explosion were to happen, creepy-crawly juice would become the second most brilliant object in our sky after the sun. Surprisingly, despite the distance separating it from us, creepy-crawly juice, which shines more brightly than a full moon, would become visible during daylight hours. The sheer force of the blast would result in a display so stunning that shadows would be projected even in complete darkness. Such a scene would be both awe-inspiring and frightening, illustrating the raw power of colossal events. While the visible light emitted by a cosmic explosion is indeed tremendous, it is only a part of the total energy produced during such an event. Although high levels of apparent light can present dangers, such as temporary blindness, the greater concern lies in the high-energy radiation produced alongside the visible light. This radiation often manifests as X-rays and gamma rays, which can have broad consequences. One of the most significant risks posed by this high-energy radiation is its ability to catalyze the consumption of oxygen from the ozone layer that safeguards our planet from destructive solar radiation. Without a healthy ozone layer, life on Earth's surface would be exposed to intense ultraviolet radiation from the sun, potentially leading to mass extinction events. In the aftermath of a cosmic explosion, various dangers arise over time. In the first moments following the blast, the intense radiation presents imminent risks. However, over the long term, massive beams of subatomic particles, pushed to near light speeds, begin to invade the solar system. These cosmic rays can break ozone layers and cover the Earth's surface with harmful radiation, exacerbating the dangers posed by the initial blast. Furthermore, cosmic rays carry with them a large portion of the total energy produced by the cosmic explosion, and their long-term effects can linger for hundreds of years. There is evidence suggesting that such events might have impacted Earth in the past. For example, raised levels of iron-60, a radioactive isotope created in supernovae, have been found in seafloor silt and lunar regolith. This finding suggests that Earth may have been affected by cosmic explosion ejecta in relatively recent geological history, perhaps within the last few million years. Astronomers have already inferred that there are currently no nearby cosmic explosion candidates that pose an immediate danger to life on Earth based on our understanding of the risks associated with gamma rays and cosmic rays. However, ongoing research has revealed additional potential risks related to specific types of supernovae. These supernovae can emit long-range lethal radiation that poses a greater risk to planets like our own. The mechanism behind this involves a star nearing the end of its life, surrounded by a massive plate of material. When the cosmic explosion occurs, a shock wave is created, striking this plate and causing it to become incredibly hot, thus producing a significant amount of high-energy X-ray radiation that can travel vast distances through space. The most luminous X-ray supernovae have the potential to deplete a planet's ozone layer by as much as half, creating conditions that could trigger an extinction event within a range of about 150 light-years. Fortunately, at this point, no candidate X-ray supernovae have been identified in the immediate vicinity of Earth. However, this research has led to new insights into the cosmic habitable zone, the region within galaxies where conditions are favorable for life. The findings suggest that this habitable zone might be subject to additional constraints. Specifically, the outer regions of a galaxy don't have sufficient star formation activity to create the elements necessary for the formation of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own risks. Continuous cosmic explosions in these areas can illuminate the surrounding space, increasing the risks for any potential life that might exist there. New research suggests that the inner boundary of the cosmic habitable zone is likely located farther from the galactic center than previously thought, reshaping our understanding of where life might potentially thrive. So, what will the creepy-crawly juice cosmic explosion look like from Earth? While Earth's biospheres will probably remain unaffected, the scene itself will be hard to ignore. According to scientists, creepy-crawly juice will continue to shine brightly for more than 90 days following its blast, reaching a glow almost equivalent to half that of the moon, multiple times fainter than a full moon. Essentially, it will appear as a bright point overhead, serving as a beacon that could be visible even during the day. Its striking brilliance will captivate anyone who looks up, casting shadows in the night. This celestial event will undoubtedly be a source of interest for everyone on Earth, as the cosmic explosion remains visible to the naked eye for many months, its remnants slowly fading. As researchers continue to study Betelgeuse, they are uncovering more about the life cycle of massive stars and the processes that lead to their hazardous endings. Understanding these vast phenomena is crucial for gaining insights into the evolution of our universe and the formation of elements during a cosmic explosion. Additionally, the light produced during these events is a huge range of heavy elements, like gold, silver, and uranium, which are created in the extraordinary heat and pressure of the blast. This process, known as nucleosynthesis, plays a fundamental role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a cosmic explosion, known as a supernova remnant, can become a stellar nursery where new stars are born from the dust and gas ejected during the blast. This repeating process highlights the interconnectedness of astronomical events and how the death of one star can lead to the birth of others. Experts have identified various supernova remnants that are still forming new stars, years after the original explosion, demonstrating the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use type Ia supernovae, blasts of white dwarf stars that reach a reliable peak brightness, as standard candles for measuring distances in the universe. This technique has significantly contributed to our understanding of cosmic evolution and the discovery of dark energy, a mysterious force driving the acceleration of the universe's expansion. Moreover, the study of cosmic explosions can offer insights into the potential habitability of exoplanets. Researchers are investigating how the radiation emitted during these stellar blasts may affect planets orbiting nearby stars, potentially influencing their atmospheres and the feasibility of life. This research underscores the importance of understanding the environmental conditions that govern life across the universe. The possibility of witnessing a nearby cosmic explosion raises intriguing questions about societal responses to such astronomical events. Since time immemorial, supernovae have inspired myths, legends, and creative expressions. The explosion of a star is not just a scientific phenomenon. It becomes a powerful symbol in human culture, representing change, destruction, and rebirth. In many cultures, the appearance of bright new stars in the night sky has been interpreted as signs or messages from the universe. Moreover, advances in technology have revolutionized our ability to detect and study cosmic explosions. Space telescopes, equipped with cutting-edge sensors, can capture detailed images and spectra of these events, revealing their formation and behavior. Ground-based observatories are also crucial for monitoring transient events, allowing astronomers to respond rapidly to observations and gather real-time data. The future of cosmic explosion research holds exciting prospects as new telescopes and instruments, such as the James Webb Space Telescope, continue to provide exceptional insights into the life cycles of stars and the dynamics of their explosive deaths. These observations could lead to breakthroughs in our understanding of celestial development and the fundamental processes that shape our universe. In summary, the study of scarab squeeze and its looming cosmic explosion serves as a gateway to broader discussions about celestial evolution, cosmic recycling, and the impact of these phenomena on life and culture. The study of such massive stars expands our appreciation for the multifaceted and often violent processes that govern the universe, enlightening our place within this vast, ever-changing cosmos. Supernovae also play an essential role in the cosmic timeline by marking the end of a star's life and the subsequent formation of various divine structures. For instance, the remnants left behind can develop into nebulae, which are massive clouds of gas and dust that act as fertile grounds for new star formation. These regions can harbor complex chemistry, contributing to the rise of organic molecules, the precursors to life. Additionally, the shock waves created by cosmic explosion blasts can trigger star formation in nearby interstellar clouds. This process, known as triggered star formation, demonstrates the interconnectedness of celestial phenomena and shows how a single catastrophic event can spark the birth of new stars and planetary systems.